Hi, I'm John Amond. I'm Professor of Chemistry Emeritus at Montana State University. Today I'd like to talk with you about spontaneous electrochemical reactions, reactions that push electrons from one place to another and in the process can perform useful work. This is how batteries work. I'd like to shift to my lab bench and show you some material. I have a flashlight battery, I have a flashlight bulb and some test leads. There's a lemon with some zinc and copper in it, and a microlab with some test leads connected to its voltage input. For the first experiment, I'd like to connect the battery to the flashlight bulb, and here's a quick look at how that looks. Let's move to the desk and try it out, and I'll just connect these leads, one to each end of the battery, and you can see the battery is doing useful work there, lighting the light bulb. Now I'd like to try this again, but this time I'm going to connect it to the microlab. Our voltmeter, it has a black input lead and a red input lead, and I'll connect the black to one end of the battery and the red to the other end. And if you watch the meter, it goes up, it says about 1.6 volts. And if you notice also, there's a little light bulb that lit up indicating electrons are moving, and there's an arrow showing which direction it's going. If I turn the battery around, it still reads 1.6 volts, but the electrons are shown as going the other way. By convention, if the electrons go in the black lead on a voltmeter and out the red lead, the voltmeter reads positive. Okay, that works. Let's try another experiment. If I can look over here, I'm going to remove my light bulb to just clear table space. Here is a lemon, and it has a piece of zinc pushed in it, and it has a piece of copper pushed in it. And if you switch back now and look at the microlab, this is reading a voltage also. I'll unhook it, goes down to 0, touch it back, goes up. The battery is producing about 0.8 of a volt. The electron, or the voltmeter, can tell us which way the electrons are moving. They're going in the black lead, which is connected to the zinc, and out lead, the red lead. So the electrons are moving from the zinc on this side to the copper. What's happening here? These are electrochemical reactions. They're called redox reactions, and redox is a combination of two words, reduction and oxidation. Reduction is the gain of electrons. The electrical charge is reduced. It goes negative during gain of electrons. Oxidation is the opposite of that. Electrical charge moves positive when electrons are being removed. In the lemon battery, what was going on? Well, the zinc was giving up electrons, ran in the black lead of the voltmeter across and back to the copper. What's going on those two electrodes? Copper ion surrounding the metallic copper has gained electrons to become metallic copper. Zinc was zero charge, giving up electrons to become zinc ion. These electrons moved from zinc to copper in this direction. The copper was being reduced, the zinc was being oxidized. Redox reactions always occur in pairs. One of them is a source of electrons, the oxidation reaction. The other accepts them, the reduction reaction. Batteries run on oxidation and reduction reactions. The difference in electron attracting ability of the two metals involved determines the voltage that will be produced. And also the concentration of the ions that are reduced and oxidized will affect the voltage produced. More about this in the next video.